Hello, this is Mr. T. I have a tutorial today on using integration for solving an application problem. In this particular case, let's read the problem. We're on an asteroid called T-Droid, and on that asteroid the acceleration due to gravity is negative 12 feet per second squared. An object is thrown upward with an initial velocity of 30 feet per second, and it's thrown from an initial height of 5 feet. And we want to know what is the maximum height that the object will go. So let's look at our words. Let's talk about the information that we're given. So we are given that the acceleration function is negative 12. The acceleration here is a constant, or at least we're assuming it's a constant function. We are given that the initial velocity, so that's v at time 0, v of 0 is 30. And we are given that the initial height, let's call that h of 0, is 5 feet. Now we want to find the maximum height. So let's look at what we know. If we remember back from when we did derivatives, we started with a position function, and when we took the derivative of the position function, we got velocity. And then when we took the derivative of velocity, we got acceleration. So here we're working backwards. So velocity is going to be the integral of the acceleration function with respect to time. And our height function, our position function, will be the integral of velocity with respect to time. So if we work our problem, we get started here. Let's find our velocity function. So v of t will be the integral of our acceleration function, which was a constant, negative 12. Using our integration rules for integrating a constant, this would be negative 12t plus c. Now we were given the initial velocity, that will be our c, but if we didn't remember that c was the initial amount, we can substitute in. So for v of t, we've got 30 feet per second, and that was at time 0. And we can see if we solve that, we get c equals 30. So our velocity function is negative 12t plus 30. Now we just said on the previous page, to get the height function we need to integrate velocities, so that's now negative 12t plus 30. We're integrating that with respect to time using our basic integration rules. We get negative 12t squared over 2 plus 30t plus c. That simplifies to be having a height function of being negative 6t squared plus 30t plus c. So we plug in for our initial value here, and our initial height was 5 at time equals 0. And we can easily see here that our integration constant was 5, so our height function is negative 6t squared plus 30t plus 5. Okay, so we have these functions for our velocity and our height. If you remember when we did these motion problems at the beginning, max height happens when velocity equals 0. So if we solve our equation, negative 12t plus 30 equals 0, we get t equals 2.5 seconds. So to find our height, we need to evaluate h of 2.5. And if we plug that into our equation here and calculate, we get 42.5 feet. So with this problem, we did not have to memorize the formulas for our velocity position functions for motion. All we needed to know was our acceleration due to gravity on our particular planet and some initial information. So I hope this helps. Just a hint, this is going to show up on an upcoming quiz.